Hi guys, so today we're going to go over the cross product of two vectors, which can help you find the torque applied by a force. So if you look at the image below, I'm kind of giving you the method on how we're going to apply it. So if you're given two vectors, I just want to note this, if the vectors are given in linear combination form, meaning I, j, and k, then write your answer in linear combination form as well. If it's given in component form, meaning with these brackets, then answer in component form. So with that stated, I'm going to start by setting up the two vectors. We're finding the cross product of vector u and v. So I'm going to just try to line up exactly how you see it above. So we're going to put I, let's find a lighter blue, J in red, and K. So these represent X, Y, and Z axis. So if you look at the linear combination form, the constant for that would be 1, 2, and 1. So those are the numbers we're writing for vector u, which in the diagram's case would be vector A. So that would be 1, 2, and 1. And for the second one, the coefficients for I, j, and k would be 3, 1, and 2. So the only thing that linear combination does is tell you which one is the x component, y component, and z component, because they could technically switch it around since it's adding. So the I, j, and k tells you which is which. So from here, what you're going to do when you have a 3 by 3 is that you're going to take I, and we're going to make it a 2 by 2 matrix, meaning I'm going to take, since I'm using I, I'm not going to use the rest of the values in that column. I'm going to take 2, 1, 1, 2. So notice how they set that up as well. So you're not going to use that column. And then we're going to take the second variable, which is j. And again, make sure that you're not using the values in that column. So we're using 1, 3, 1, 2. And then finally, plus k. So again, since we're using k, we're not using the values in that column. And it will say 1, 3, 2, 1. So this should make things a lot nicer because when you're working with a 2 by 2 matrix, you're just going to cross multiply to solve. So for instance, I'm going to bring down the I, and then from here, always left and down first. So 2 times 2 would give me 4, and then minus 1 times 1, so this would give me 3i. For j, bring down the minus j, and note that j is minus. I'm going to do the same thing again, left and down first. 1 times 2 is 2, minus 1 times 3 is 3. Now 2 minus 3 would give me negative 1, but I'm taking negative 1 times negative, technically 1j. So this would give me positive 1j, and you don't really see the 1 in front of the variables, so we're going to leave that be. And then plus k, and again cross multiply. 1 times 1 is 1, minus 2 times 3 would give me 6, so 1 minus 6 would be negative 5k. So my cross product of the vectors u and v would be written this way in linear combination form, which I'll leave as, since it's also written as linear combination form. However, if you're going to write it in component form, it would just be 3, 1, negative 5. And that's pretty much it. All right, guys, I hope this helps.